Hi, everyone. So this is runtime types at Crunchbase. I'm Themba Fletcher. I manage the core platform team at Crunchbase. And I'm here today to talk about metadata-driven platforms, but not just yet. So first, I'd like to start with a question. And the question is about the underlying nature of our data. What's the best way to think about it if we're going to build a bunch of services on top of it? Is it a generic graph, or is it a collection of typed relations? And of course, this is an arbitrary choice, but we needed to get some code written, and we needed to pick something up front. And so it's awfully tempting to choose to think about these as typed relations. And why is that? Well, it's because we love strong, static types. We love our compile time safety net. We love it so much that we built our whole platform on Scala. And we're really proud of this bias. But when you design a platform, you're dealing with the interface between systems, and suddenly, very rudely, you're back in the land of runtime type checking. And it kind of hurts, right? Someone sends you garbage, and you have no choice. You throw an exception. I mean, you return a 400 error. So, yeah. Or even worse, this unparsable garbage is on a topic, and it goes to the dead letter queue. And someone's going to get right on that, right? Right, we're going to handle this. So what do? There's a ton of type systems out there for platforms, right? OpenAPI, Avro, Thrift, Protobuf. And we pick type relations up front, and there's a bunch of ways to impose these type safeties on platforms. And so you pick one, or you pick two, and perhaps that helps. And now you've got types between your systems, and everyone knows that a person is a person, and it's not a company, and it's not an event, and it's not an investor. And we use code generators, right? We can create case classes from our type specs, and we push those types back all the way into compile time for our services, and it's really nice. And you put a little translation layer in there, and what we call that an anti-corruption layer in domain-driven design. You put that nice translation layer in, and your business model is separate from its wire representation, and then this is really good. Like, this is a nice, strong system. Great. So this is what we're going to build, right? CQRS event sourcing. Beautiful, simple write commands flow into this system. Reads, they're faster than fast, right? Everything's optimized. Searches are pre-optimized. They're nearly trivial. And we wanted to maximize type safety. So we brought in Avro, and we brought in OpenAPI. We brought in Avro for the Kafka side of things because it's nice and tight, and OpenAPI has great documentation. So, and we like to be clever. So we ran a code generator across the API spec, and now we have case classes for all the business objects on the site, right? Our responses are fully spec'd out. We know what a company looks like because it's in the spec. And get this, we got a surprise boost because we defined our query language in this API spec as well. So now the TypeScript code gets a generated client, and we know exactly how to search the site without ever sending garbage to the back end. We've got best-in-class type safety for platforms, right? Well, at least the green areas are covered. And the client-side coding experience is really nice. Well, hang on. So we're going to add a new derived field to the person. We forgot to put the full name on there, right? It's just first name plus space plus last name. Trivial, right? We're going to change the spec. We're going to update the denorm engine. We're going to run the migrations and the denorm storage, update the read service, update the client. Done, done, done. Oh, we just got a lot of exceptions from the denorm engine. That was a rookie mistake, right? Forgot to run the migrations before we, yeah, okay. So update the spec, then run the migrations, update the denorm engine, update the read service, and then no sweat, right? And then 5,000 bad request errors from the read service in the last 10 minutes because CD ran some completely unrelated feature. The client got deployed before we finished the migration, and So next time we'll run the migrations, then we'll update the read service and the denorm engine in any order. Finally, we can update the spec, redeploy the JS code. But we need the spec first to update the read service because we're typed. What do you mean product wants another field on companies? I haven't finished documenting to do this yet. So this is kind of awful. This is not even a big platform, and we're already writing specs about rollout order and managing dependencies between systems. I thought types were supposed to save us from all this. And then there's more here than just getting stuff out in the right order. We want to make sure that the right indices are built, and we want them out and deployed before someone's phone goes off because the 95th percentile on the read service is looking weird again. And what about the API spec? It's kind of getting bloated, right? We have 34 types on Crunchbase, and not like business objects like users or subscriptions or something. No, we have 34 distinct entities that we store in the graph. So it's a big spec. Also, I lied. All this, I lied. We never figured out how to specify search queries individually for these entity types in our API spec, and we never tried because we didn't build any of this stuff. The product and engineering friction in something like this, that would have killed it before we ever went live with the first piece of it. So instead, what we built our core platform on was this. We removed the type specification for graph entities from our API spec completely, and from Avro, it's gone. Instead of having compile time safety on things like companies, on people, and on investors, we take that safety against the concept of a generic entity and its type definition. And this thing, right there in the middle that metadata serves, is called an entity definition, entity def on our platform. And so by doing this, we take our type safety and we extend it out to all the areas that are now in blue. So what's metadata? Let's dive in. So at its heart, it's just a collection of entity defs and a collection of field types. Entity defs tell us what fields and relationships are defined on an entity, what types of fields we're dealing with, and what the cardinality of any given relationship is, so forth. Entity definitions are things like organization, job, person. Field types, that's like string, UUID, identifier, date. And then fields are like the name on a person, the start date on a job. And then relationships, well, they just tie them all back together. We're in graph land. So through all this, we've managed to abstract away from the API all the details of the denormalizations that we're doing. If you do want a search on Crunchbase now, you do it in terms of the collections available to you in metadata. So collections are the plural form of entity definitions, so this is like companies. But they're also defined by relationships, a company's employees. In your query parameters, these are fields from the target entity definition, and then you'll need an operator. Get that from the field type, and then, oh yeah, your argument. And maybe you should make sure that that matches the field type as well, so we can do a nice comparison. And that's that. You know, the command language is nice. It's graph-oriented. The query language gets to be more pure too. It's graph-oriented now instead of companies. People, it's type safe all the way down. But our update problem from before, where we couldn't figure out how to reliably roll a schema change out and all the associated code in the right order without a multi-step document, well, now you just change the metadata, and that's it, you're done. I mean, it's event sourced, so you're probably going to have to reflow, but you are done, and that's an automated system. That's not a spec I have to write. And so the other fun thing I've done, we've taken the graph types and we've made them a request time implementation detail. All these services in the core loop, and this includes the JavaScript in our front-end code, they're all metadata interpreters. Until the very instant of a request, they have literally no idea whether they're going to be serving out companies and people or puppies and brunches. It just doesn't matter. So how do you change metadata? In this system, the way we do it is you provide it with entitlements. Entitlements are roles, and really the only difference between an entitlement and a role is that an entitlement has no hierarchy enforced. So if you can write to our system, you're probably logged in. We're going to have an entitlement for each of those facts. This gives us really, really fine control over the metadata and the permissions that are derived from it. So we use all sorts of other entitlements, not just user-facing ones, to alter our permissions. So for example, if we have a data connector talking to some external API, and it's going to load a whole bunch of stuff into our system, we don't want it to run amok and destroy everything. So when we program it, we give it an entitlement just for its use. And it can only see the metadata it's allowed to see, and it can only alter the things it can alter. And that gives us a little bit of extra safety. And type errors? So those are features now, right? You remember that the platform exception I said was a bad request, or the bad request I said was a platform exception? Well, it's still possible. But now, when you get a metadata-driven permission error, we're going to return a set of entitlements in your response body. And you're going to take those responses, the entitlements out of that response, and you're going to hand them to billing service, and it's going to give you a list of products that you can buy to get your metadata into a shape that would allow you to do the thing that you originally asked to. So what's that? Did we just do a type system-driven upsell, or maybe I'm just pushing the analogy maybe a little further than it needs to go. So let's break the analogy even further down, because we put all kinds of things in metadata. So we put validations in, and I'd really like to stand here and claim that validations are refinement types, but nah. Okay. We have display instructions, themes, layouts, labels, all those things. We have application limits, maximum number of rows in a search result, that sort of thing. Those go in metadata. And query templates are really cool. So if you go to Crunchbase and you see something like the number of funding rounds on a company, it's a link. That's a link to a piece of aggregate data that's stored on the company record. But when you click it, there is a search defined in the field definition. So you just land right back into search. And this lets you have a really nice, beautiful product loop where you click on something on a profile page, you land on search, you find a new profile, back and forth, back and forth. And it's all just sort of a side effect of having metadata. So drawbacks, of course, right? One that immediately comes to mind is field types are really, really hard to modify. This is like if you were in Postgres and you decided you wanted to update the way a varchar works. So we don't do that. You can, of course, add new field types, but an update is just pretty much out of the question. The next one is maybe more of a social concern. There's a learning curve to working with this stuff. This isn't, I think, standard practice across the industry. So you need some time after onboarding to really develop an instinct for what goes in metadata, what doesn't, what behaviors need to be tied there. And authoring it is not always trivial. We've built a lot of guardrails, a lot of extra tests, all kinds of things to improve the authorship experience, but we can always use more tools. And finally, and this is less of a drawback in practice than it was just a real surprise for us, this actually impacts A/B testing quite a lot. So we thought when we did A/B testing that metadata service would be the source of it. It would just serve the flags. Turns out that that doesn't work at all. What we actually need is both A and B in the metadata. And then when you take the flag in the client app code, and it makes the decision about which piece to use. Works well, but it was a surprise. So, did we achieve the goal we set out to achieve? Did we build something that was both agile and safe? In the first few months immediately following the launch of our platform, our tiny little data engineering team, I think it was 3.5 people at the time, integrated with 8 distinct data partners, deepening our profile experience with 4-pay data. And they did this by authoring metadata, by writing a connector, by dropping payloads on a topic. That's it. No platform code changes, no migrations, nothing. And that feels like a win. The second one is really my favorite, though. It's not at all uncommon for me to come into work on a Monday morning and find a pull request directly from a product manager against metadata service. They adjust their labels, they rearrange the content on profile pages, they adjust query templates, And all I have to do is approve the PR. And I really like that. And both of these hint to me we may have found a sweet spot on which to balance this type safety against product agility. So we're getting to the end. What's next? We're looking at multi-tenancy and the possibility of truly private data on our graph. And we're not sure how we're going to build this yet. But when we do, we're going to have to find new ways to express these concepts, and we'll probably do them through metadata. But more immediately, my biggest concern is how we scale this concept across a slightly larger engineering organization. We've got 30 engineers at Crunchbase. We're going to 80. We're going beyond. And there's going to be no shortage of new voices clamoring for new features, pushing this system in all kinds of directions. And so finding ways to creatively harness this while keeping it true to its original design goals is going to be a really fun challenge. And that's it. Thank you. Of course, of course, I have to mention that we're hiring, so if you'd like to come talk to me at the booth, that's great. I'd love it.
Well, that was awesome. There should be questions, because there's a really cool concept and implementation. Anyone?
Thank you, Themba. That's a great talk. And so I'm just curious how, like, originally the decision to use all this, some of this tech, Scala, Kafka, maybe you can talk a little bit how this came about.
The metadata part or the
stack,
having
the technology
CQRs? Oh, the tech stack. So the tech stack's not my design. This is not my architecture. And so what I was really trying to do was focus on the metadata side of this thing. I think you take some constraints on up front. You say, I want to build a reactive system because I think it's better. And I think you say, I want to be type safe because I think it's better. And does that answer your question or no? Yeah.
Any other questions?
Yeah, thank you for your talk. I was curious, can you drill down a little bit into the metadata service and what that's built on?
Oh,
and,
sure.
You know, what components are there?
Sure.
Thanks.
So it's an Akka HTTP service. It has no backing store. That's actually one of the neatest things about it. So metadata is it's completely represented in Hokon because we really did not want anything to do with XML. So so it's Hokon because the concept of metadata has there's inheritance in it. There's mix-ins. Hokon is kind of nice, right? You can just mix things in where you want them, and we can do both. You can inherit from things by mixing in, and you can also bring everything back together, you know, and solve the diamond problem that way. Yeah, so other than that, it's a very simple little Akka HTTP service built on. It loads its configuration at runtime. It takes entitlements off the wire, calculates the permissions at the very last second, and serves a response. Serves a big bag of JSON.
Anyone else?
How are you validating and testing that the metadata that you enter is correct?
Pedantically. So the one piece of work we did have to do in those first few frantic months after we launched this platform was account for the fact that metadata was no longer being authored by the author of the service. It was being authored by strangers. And the biggest problem we had were referential integrity errors. So we had to go back through metadata at every point, every reference we make to something else, we have to make sure that it's clean. And we're not exposing the entire schema to every requester, so it's tough. You know, you take a set of permissions, you see what's in the metadata, and then we walk over it several times, looking, checking for every reference, making sure that all the right things were filtered. Is that?
How do I know when I enter the metadata that what I'm putting in there is actually going to work to do what I want?
Well, no, we don't know if it's going to do what you want. We can assert that it's consistent, but you can't actually prove that it does what it wants. That's where you'll write an integration test against the client app code to say, okay, I expect this piece of content in this location. I expect this kind of thing, because you can't at the service know what the intent is from the product level.
Anyone else? Well, thank you so much.
Yeah, thank you guys very much. It's been an honor.